In this session, we will delve into the setup for testing and examine the electronic control unit. Get ready to explore the process of configuring and testing electronic components. Upon completion of this exercise, participant will acquire the ability to identify the electronic control unit (ECU) and engine scanner. Additionally, they will develop skills in thoroughly inspecting and understanding the electronic control unit in the context of automotive technology. Recognize and name essential components of the multi-point fuel injection MPFI system and sensors in an automobile, such as the ECM, flywheel, oxygen sensor, and ignition coil. Demonstrate the ability to physically locate each component on an actual automobile. This includes hands-on identification, aiding in practical application of theoretical knowledge.
Tools and equipments required: trainee's toolkit, engine scan tool, a running condition of EFI vehicle, gloves, cotton waste, soap oil. Let us start by identifying the electronic control unit, ECU, and engine scanner. This session focuses on understanding and testing the ECU, vital in diagnosing and ensuring optimal performance of the vehicle's electronic control system. The first step in this procedure is choosing the service manual. Selecting the appropriate service manual for your vehicle is crucial as it provides accurate documentation essential for maintenance and repairs. Following the correct manual ensures precise guidance, promoting effective troubleshooting and enhancing overall vehicle performance and longevity. The next actions explain how to physically set up the scan tool. This involves connecting the test cable, making sure the ignition switch is turned off, and using the right cables and adapters to connect the diagnostic connector. Attach the accurate diagnostic connector. Link the scan tool's test connector cable to the diagnostic connector. Utilize the correct adapter if needed. It's important to note that OBD2 scan tool get power solely from terminal 16 of the diagnostic connector, eliminating the need for supplementary power connections, simplifying the setup process for users. After connecting, observe the scan tool's screen to ensure it functions correctly. Most scan tools conduct a self-check, alerting technicians to potential software or communication problems. This step verifies the tool's operational status and prompts necessary action for issue resolution. Now the tool needs some information about the vehicle. So all you need to do is to enter essential vehicle information into the scan tool. Modern OBD2 tools automatically retrieve VIN when the ignition is on, facilitating code checks. Older tools necessitate manual input of details like year and engine type, typically found in specific VIN characters, ensuring accurate diagnostics in both scenarios. Once the ignition key is turned to the on position, the scan tool checks for trouble codes and any detected codes are listed. The user. Here you can consider yourself as the user. So you will be guided to consult the scan tool literature or service manual to interpret these codes, crucial for pinpointing specific issues within the electronic control system. The subsequent step involves erasing the trouble codes, switching off and on the ignition to verify if the issue persists, and checking the engine indicator. Ensure the engine indicator is in off position. If not, there might be issue with the electronic management system EMS. After completing the test, the ignition is turned off and the scan tool connection is removed from the diagnostic connector. Sensors play a crucial role in vehicle electronic control systems. Sensors are devices that convert or transduce physical quantities. The process involves converting physical quantities such as mass, pressure, volume, temperature, or acceleration, referred to as measurements, into output signals, typically electrical, which are then used as inputs for control system. Let's get familiar with an understanding of the multi-point fuel injection MPFI system and various sensors in an automobile. Let's get this started by identifying the different sensors of the engine. Locate the engine control module ECM, which is the heart of the operation and is in charge of running the MPFI system. Locate the important parts like the flywheel and the crankshaft position sensor. These sensors are positioned within the crankcase and crank pulley. These sensors are mostly utilized to monitor the injection timing and ignition timing of the engine, which are dependent on the speed of the vehicle. In order to do both qualitative and quantitative analysis and control as well as monitor efficiency. The exhaust manifold is the location of the oxygen sensor. The device is utilized to quantify the amount of unbound oxygen present in the emissions from an engine. This measurement is crucial in determining the optimal timing and quantity of fuel to be used. Mass airflow sensor. It measures the amount and density of air entering the engine at any one moment and is located in the intake manifold or throttle body on MPFI. For the engine's balance and proper fuel mass delivery, the data is crucial. Hall effect sensor. A magnetometer is a device utilized to quantify the intensity of a magnetic field. Its output voltage is directly proportional to the strength of the magnetic field passing through it. Hall effect sensors are utilized for many applications such as proximity sensing, location, speed measurement, detection, and current sensing. This sensor is responsible for monitoring the temperature of the incoming air and the coolant in the engine. When the temperature rises, the resistance decreases and the voltage output increases. This prompts the ECM to detect the issue and interpret the required power supply while sending a signal. Find the ignition coil, which is required to convert low voltage electricity into the high voltage electricity, which is required by spark plugs. Vehicle speed sensor. In order for the computers to control the torque converter, clutch lockup, shifting, etc., this sensor keeps an eye on the vehicle's speed. The sensor is found on the head of the speedometer, transaxle, or gearbox. Start by looking at the fuel system's common rail, pressure regulator, supply line, injector, and accumulator. Then move on to the fuel tank, electric fuel pump, and fuel filter. The location of the component can be found in the engine block, cylinder head, or intake manifold. It is utilized to detect vibration resulting from the engine's detonation. This information is highly valuable for determining the injection and ignition timing in diesel and petrol engines respectively. Explore the sensor network, which includes the idle speed actuator, the intake air pressure sensor, the throttle speed switch, and the engine temperature sensor. Finally, locate the spark plugs. This is very important for lighting the mixture of air and fuel in each cylinder.
Let's recap this topic. In this topic, you have learned that the first step in this process is choosing the service manual. Selecting the appropriate service manual for your vehicle is crucial as it provides accurate documentation essential for maintenance and repairs. Following the correct manual ensures precise guidance, promoting effective troubleshooting and enhancing overall vehicle performance and longevity. Hope you have a clear understanding of this. Do this exercise with help of your instructor. Thank you.